here? Any other people come in? Do you know that they will come, or are we good to start? Okay, so we'll start our lecture on analytics and business intelligence. So before starting, I would like to know something about yourselves. So first of all, I'll introduce myself. I'm Nishadi Aryasinghe. I'm a graduate from University of Ruhuna and currently working at University of California. So I've been doing this analytics and business intelligence course for your previous batches for about several years. Okay, so how about you guys? Can each of you introduce yourself? Maybe your name, where you're from, what you are doing, are you working or full-time studying or what? Yeah, somebody start. Can somebody start?
Yes, madam. I'm Chamesh Mihran from Beliatta, and I have completed my higher diploma in computer-based information system from NIBM, and I previously work at Alvis Lanka Private Limited, and nowadays I'm retired from that company, and nowadays I'm trying to complete my graduation from ICBT.
Okay, good. So, yeah. Anybody else?
I'm Himasha from Veligama. I studied at St. Thomas Girls School, Mathura. I have done diploma and higher diploma in computer science at NIBM. I worked 6 months at Training eVision Microsystems in Training Business Analyst. Now currently I'm working MAS Holdings.
Okay, good.
That's all.
So, MAS Holdings, where in which branch are you working?
Twinary, Foster Lane.
Sorry?
Twinary, Foster Lane, Colombo 7.
Yeah, Column 7. Okay, okay. Okay, so yeah, anybody else? Who's next?
I'm Vinisha. I'm from Mathura. I studied at NIBM. Previously, I worked in Department of Government Information.
Okay, good, good. Yeah, anybody else? Anjali?
Hello.
Okay.
I am Anjali Keshani. I am from Hambantota. I have completed Management Information Systems Diploma at NIBM. I am not working yet.
Okay. So all of you guys have gone to NIBM and completed some level, and then you have started here, right? Okay. Okay, so good to know about yourselves. So we'll start our lecture on analytics and business intelligence. So I just asked about what you are doing, like what in which field you are working, kind of thing, because I think most of you guys are working in the management side, right? So, so this lecture or this course will be very valuable for you. So if you like, you will gain knowledge about analyzing certain tools regarding analysis and business intelligence side. So I think it will be very useful for you guys, and try to make the most of this lecture series. So in our lecture series, we are mainly focusing on data analysis, data mining, analyzing, and most of all we are focusing on geographical data, geospatial data. Okay, so don't be afraid if you don't understand about geospatial data. Those words will be new for you. Some may know, some might not know. That is okay. So we are here to learn. So, and I want to tell you something. So when I ask your opinion, please answer. Right? When I ask you a question, please do answer, because it doesn't matter whether your answer is right or wrong, whether your answer is correct or wrong. It doesn't matter. Whatever you think, or whatever you think based on the knowledge that you have gained so far, you can think something. You have studied up to some level, right? You have the ability to think something logically, right? So you can you should give any answer that you think which is right. Okay, it doesn't matter whether it is right or wrong. Maybe the answer might not be complete answer, but you should talk, right? So we all of us are here to learn. There will be a lot of mistakes, so try to minimize those mistakes by learning, right? So nobody is laughing at you when your answer is wrong, or when your opinion is wrong. Nobody will laugh at you, because all of you guys are here to learn, right? Okay, so that was something apart from the lecture. Yeah, you can see the learning. Can you see my screen? I hope you can see my screen by now. So if you are not able to see my screen, please mention it. Okay, so so the learning outcomes of our lecture series will be as this. So I have listed them down. I think you can find this in your student guide or some document like that. So we are focusing on key technologies which is related to data warehouses, data analyzing, data mining, predicting something based on data. And as I mentioned, we are focusing on geospatial or geographical data mainly, right? So we will associate with real world scenarios. So data which is obtained from real world scenarios, we will use them in our analysis. And it is like we can build stories, right? We can tell stories. So for example, we have a bunch of data. So we take that data and we do some analysis with the help of certain tools, certain algorithms or tools, and then we can come up with a story. We can say, according to the patterns of this data, according to the patterns that we found inside this set of data, we can tell something like this. Okay, and then we can tell a story. So we'll come up to that those things also during our lecture series. Okay, so yeah, this is the same. Like you can use various kind of data, and you can visualize that data. You can generate maps, generate graphs, charts, things like that. And you can visualize the data. So rather than just looking at a large Excel sheet of data, it is more understandable when we visualize that data, when we look at a chart, when we look at a map, okay, or maybe when we look at a graph like that. Okay, so we can also build models, and we can gain business intelligence from that data. So we can analyze the data and we can gain certain intelligence about that data, and we can develop models. So model developing means we can create a framework based on the existing data, and then we can use future data and we can predict, not future data, maybe it is like this. We can use past data and we can build a model, and we use current data in order to tell the future. So that is what we do with models. We use past data and then we build a model, right? Then we use the current data and we predict something in the future, right? It is like what it is like we are like when we create a block to make a dress. Let's say we create a block to make a dress for ourselves, right? So we use that block. So we get the measurements of our body and then we create a block. So that block is a model. Okay, so this model will be used to build or create dresses in the future also. We can buy some clothes and come and then we use that block, the block which is currently existing, and then we can make dresses that we can which we can use in the future, right? So it is something like that. Okay, so this is the content, the main content that we are talking about: online analytical processing, data analysis and data mining. We'll talk about predictive analysis and mostly about geospatial technology, social network analysis, those kind of things. Okay, so so we talked about this word analyzing. From the beginning of the lecture, I have used this word several times. We can analyze the data and we can predict something, things like that. So what is data analysis? So data analysis includes all of these things, the whole process. We have to collect data. Before doing anything, we have to collect data. We have to measure the data that we have collected. We have to measure, and we can use computers. So in modern days, we are using computers to do any analyzing part, right? And then we have data preparation. There are a lot of techniques to prepare data. Just collecting data is not enough. It is not sufficient because there can be many errors or many issues with the data which we have collected. So before analyzing, okay, before sending that data for the analysis part, we have to prepare that data. If there are any data with errors, we have to remove them, things like that, right? So data inferencing, hypothesis testing, data mining, all of these things are included in data analysis. So we will talk about each of these things in future slides. So just keep in mind that data analysis is not only one thing. It is not only the analyzing part. It does not mean only taking the data and putting it into a computer software and getting a result. That is not data analysis. The whole process here and lots of other steps is included in data analysis. Okay. So yeah. So we will also talk about GIS, which is Geographical and Information System, and Spatial Statistics. So don't worry if you are not, if you do not understand or if you are not familiar with these terms. So we will talk about these things in future. So I have given a list of GIS and related spatial tools that can be used in order to perform analysis regarding geographical data or geospatial data. So we are focusing on geographic and geospatial data in your lecture in this module. That's why I am talking about GIS, and I have given a list of tools that you can use. Right. So the application or the software, the main software or the tool that we are using is QGIS. It is an open source application. You can download it freely and install in your machine. Or maybe I think you are able to obtain this software from your ICBT campus also. I don't know how, I don't know the recent status due to this COVID thing and all. But if you have any issue downloading and installing it, you can ask for this application or the exe file from your institute. So there are other tools, OpenStreetMap, PostgreSQL, like that. There are many other tools that you can use. So we are using QGIS, right? Okay, so these are some recommended reading that you can refer to. Mostly they are online resources, so you can obtain them online. You can read anything if you need. Okay, and remember, I will give these slides to your course coordinator, so he will upload to your maybe student portal, or he will email to you. Right. Okay. So before moving on, we will talk about what analytics is, what intelligence is, and why we are using business analytics and intelligence. Right. Okay. So before moving on, I need your opinion. So you can use this QR code. You can take your mobile phone. You can scan this QR code, and there will be a question. So this is the question: what is analytics? So you can give an answer. There will be a place where you can answer it. There will be a place where you can type the answer. Okay. So if you are somehow unable to scan this QR code, you can use this link. Right? You can use this link in order to answer the question. So can you like take a couple of seconds and do it? So have you answered, all of you? Okay, so this is actually the some answers given by you and your previous batches, right? So when I ask the question, what do you mean by analytics? These are the answers that they have given, right? So most of the people have given scientific process in data. So analytics is a scientific process in data, using data. So analytics means analyzing data, something like that. And some have given analyzing or analytics means getting a proper understanding of the topic, making conclusion about information, that is analyzing, data processing, process of exploring and representing, check whether there are any patterns, processing the data, right? Data statistics, discovery of meaningful patterns in data. So when somebody asks what is analyzing, you can say something like this, right? Understanding about the information that you have collected, separating something into components, right? Method of data collections and getting idea about the data, right? Discovering data, things like that. Discovering, interpreting, right? Discovering, interpreting, communication, computing, business analysis refers to technologies for solving business problems, monitor the insights, things like that. So you can see this is a set of answers that a lot of people have given. So if you have given your answer will be available here, right? So most of the people have mentioned about something like understanding the data or discovering meanings of the data, right? So actually it is actually something like that. So analyzing means you collect a set of data regarding to some specific field or some specific problem, some specific location, anything. Based on a specific thing, you are collecting you collect data. Okay, and then after collecting data, you look at the data and you identify or you can understand certain patterns based on the data that you have collected, right? You can understand certain patterns. So based on these patterns, you can come up with the conclusion, right? You can come up with certain ideas, you can come up with certain conclusions, or you can understand certain meanings, right? So those things are being done by data analysis, right? Discovering meanings of data. So in today's world, data is a crucial thing which can be used for many happenings or many to solve many problems, right? And data is everywhere. Data is collected, stored, shared everywhere and every time. So from the moment that you wake up any day, there is data flowing here and there, right? For example, you wake up in the morning, you use your mobile phone to maybe you put on the alarm, and then you put on the alarm on your mobile phone, and then in the morning when the alarm goes out, you wake up. So there is something called Google Calendar. If you are familiar with it, you can set reminders, alarms and things in Google Calendar. So when you wake up in the morning, you can check the calendar and see what are the tasks that you have to do today. So that data is online. That data is stored in a Google server, right? The data is private for you, but that data is not with you only. It is online. You are accessing the data from Google, right? So you can check the calendar and you see, okay, I have to maybe submit a thesis, or I have to write some course, I don't know, do something regarding to your course, or I have a lecture today and from this time to this time, or I have a meeting. So things like that you can store in the Google Calendar. So that is data, right? And then you switch on your computer or any device that you use, maybe, and then maybe you use your mobile phone and you order something. You order something from a shop. Maybe you use services like PickMe or Uber or any other delivery services. You online order some food. So that is also data. What kind of food that you are ordering, what is the price range, where you live. So your location, your current location will be uploaded or updated in the PickMe or Uber servers. So all of those things that you are doing online is a collection of data. Okay, not I mean, just because the other people can't see your private data. So for example, I can't see I don't have the ability to see your delivery services, right? The food that you're ordering, those kind of things I can't see, but that data that you are, I mean, food items that you're ordering, and your location and the price range and everything, that is a set of data, that is a collection of data. So that collection of data will be used by the service that you are using, maybe the PickMe or Uber application will use that data in order to promote something to me. So I think you have seen when you are going to order a meal, you will have suggestions, right? The app provides suggestions. So people also like this kind of food, and they will suggest you. This is the most. This is the food that is being the best-selling food. Things like that will be suggested for you. So how are they obtaining that information? Obviously, they are using the data of other people who are ordering food items. They are using that data. So the food items which is being ordered too many times will be suggested for you. Like lots of people are ordering this food, or people are commenting, giving good reviews for this food, things like that. So that is all. There is a selection of data, collection of data, right? And then after eating, maybe you browse the internet, you go to social media, you type something, you give a comment to some person, you update your status, anything like that. So there is a very large amount of data you are uploading to the uploading online, right? Now afterwards you will use a cab service again to go to some place. So there then also the journey, the fare and everything, maybe the review that you are giving, everything is uploaded. So everything is data. So from the morning to the from the start of the day to the end of the day, you are generating lots and lots of data. So all these data will be uploaded and stored somewhere in many servers, the Google server, the Uber server, Pygmy server, any server that you are any server from the applications that you are using, they will upload, they will store that data, right? So if we can take that data, if we can process that data, if we can analyze that data, and if we can generate a model, and yeah, then we can do lots and lots of predictions for the future, right? So just by looking at several rows of data, we can tell something. Then imagine what kind of predictions we can do with the large amount of data which is available in certain servers, right? So nowadays data has become a very crucial part in generating information or predicting something. Data has become a very crucial part there. Okay, so I have given you another QR code similar to the previous one. What is intelligence? So you can scan this QR code, or you can go to this link and give some answers based on the question, based on this question, what is intelligence? Okay, I'll give you a little bit of time so you can maybe think and you can answer. Okay, so this is the these are the answers that you and your previous colleagues have given regarding to the question, what do you mean by intelligence? So intelligence. So we talked about analytics previously, what is meant by analytics, and now we can talk we are going to talk about intelligence. So basically intelligence means the ability to think or learn from the past experience, right? So based on the things that you have learned, you can use them in your as your intelligence, or you can think about something and act, right? So knowledge, right? A range of aptitudes or skills, right? Use of tools and methods to analyze data. So there is technical intelligence here, using tools and methods in order to analyze data. So data analyzing, or like the part after analyzing, after we analyze the data, as I mentioned previously, we can generate patterns. We can come up with patterns, and the part that we are using those patterns to explain something, right, or to come up with a certain decision, so that part includes intelligence, right? So with the intelligence we can come up with a certain decision, right? So processing something that we have already learned, right? Using something that we have learned in order to come up with a decision, or in order to act in the future. So those kind of things is meant by intelligence, right? The ability to use, or the ability to do something itself, right? So human beings have the most highest intelligence in the world currently, right? So apart from some animals, most of the animals in the world, they act in order to live their day-to-day lives. They are not planning they are not planning their future, or a very far future. They are not planning. They survive at the moment, right? They survive the moment. So some animals are there, like ants and certain animals. So they for example, if the rainy season is coming, they gather their goods or food, and they store their food, things like that they do. But they are not planning the very far future in their lives. But human beings, they plan their future, right? You guys also, you are planning your future. You have some plan, and you are working according to that plan in order to achieve something in the future, right? So maybe you are planning to get a good job, maybe you are planning to do some higher studies, or do some deep learning in some certain subjects. So like that, you have a plan. So you are currently doing something according to that plan in order to achieve something, right? So for that, you have the ability to think and do certain things, maybe based on your past experience, maybe based on what you have learned previously. You have the ability to logically think and do. So intelligence means that thing, the ability to logically think something and act according to that, right? So it is like processing what you have learned from the past and putting it together in order to have a better future, or in order to success your future, right? So for that you can apply your past knowledge, your skills, or your things that you understand, things that you have learned, those kind of things you can apply. Okay, so we talked about what is analytics and what is intelligence. Then we come to business intelligence, right? So yeah, this is one quote that I have mentioned here. Without big data, you are blind and deaf and in the middle of a freeway. So this is related to what I have mentioned to you about data. So the whole world is filled with data. Lots of data is being generated in our day-to-day lives. So big data means a very large amount of data. So trillions and trillions of data is being generated. So there's a certain threshold. I will mention that about the value. So there is a certain threshold for of the amount of data. So that kind of amount of data is called big data, right? Very large amount of data. So this big data is being used today, even though we do not understand, even though we do not generally see the usage, but this big data is being used in order to make your day-to-day life very easy and successful, right? Mostly in the through the applications that you are using, like the cab services or food deliveries or any other application, maybe health services, any application that you are using, big data has played a vital role in order for you to easily and correctly, accurately use that application and get the services from that application very in a very friendly way, right? So that's why they mention, so without big data, you are blind and deaf and in the middle of a freeway. So if there is no big data being used, you are clueless, right? So business intelligence is used. In business intelligence, what has happened is the optimal use of company data and knowledge is taken in order to support the business. So in order to accelerate the business, or in order to support the business, the data of that company is being used in a very optimal way. So we can use data and knowledge. Both data and knowledge can be used in a very optimal way in order to make that company successful. Maybe grow in the sales, maybe yeah, things like that. So business intelligence is a set of theories, methodologies, architectures, and technologies which is used to transform raw data into meaningful and useful information for business purposes. So business intelligence is being used in businesses. So what is happened there is the raw data. So as I have mentioned previously, lot of data is generated within a business also, right? So data is being so when we take a company, so since all of you guys are working, so most of you guys are working. So when we take a company, there are a lot of data is being generated within that company also. Emails are sent from one section to another, or maybe from one person to another within the company. Emails are being sent. Forums are created. Chatting is being done rather than orally chatting. In most companies there are separate applications for chatting with the other co-workers in order to get something done, right? And then there are reports generated within the company. There are large amount of Excel sheets or any other data which is stored. So there is a lot of data moved here and there within a company. So taking this data, this set of data, and transforming this data into meaningful information, right? Just by looking at the data, we cannot understand anything, right? For example, if we take the salary, maybe an Excel sheet where salary details of the employees have been stored. Just by looking at that Excel sheet, we cannot directly say anything. We cannot understand anything, right? But if we process that data, if we analyze that data, if we put that data into a certain methodology or certain theory, if we apply that data in a theory, then we will be able to come up with some information, right? Maybe the salaries of certain employees should be increased, things like that, right? So so data is basically a raw element. Data is raw. It is not processed. It is a raw element. And then we process that data and then we create information. So here what happens here is the elements are linked. Elements of context is linked with each other, right? Data with same patterns or same preferences, same characteristics are linked with each other, right? And then information is created. When we organize this information or when we give a meaning to this information, we make knowledge, right? We create knowledge when we organize this information or when we give a meaning for this information. So let's say you have been studying since grade 1, right? So there are certain theories. So when we take mathematics, there are certain ways to add two numbers, subtract two numbers, right? Divide a number from another number. So there is a certain way of doing that. So you have been taught that way, right? Teachers have taught you how to add two numbers, how to add three numbers, how to subtract one number from another number, things like that. The teachers have taught you. So that knowledge is there with you. So whenever a person give you two numbers today, at the moment, you can directly add them. You do not have to think about the theory or any other detail before adding those two numbers. That information about how to add those two numbers, that information is there with you. It is organized inside your brain. You already know how to do that, right? Then nowadays you when you see two numbers, you unconsciously you add those two numbers. You can add them without thinking about how that teacher taught you to add these things like that. You do not need to think. Okay, so knowledge comes from applying information, organizing information for a long time, right? Then when we apply knowledge into a certain day-to-day activity or into maybe a certain problem, then we create wisdom, right? Then we create wisdom. So theories and technologies, methodologies and everything, we study them and then they become our knowledge, right? We study them again and again, and maybe we by heart them, maybe we do we test them, like we do lots of things, and then those theories, methodologies and those things become our knowledge. And then we come up with a day-to-day experience, or maybe a problem, a large problem in your company. We come up with a problem, and then we use that knowledge and apply that knowledge into that problem. So applying the knowledge means in order to solve that problem, we use the theories, the methodologies, the tools, architectures and everything that we have learned, everything that we know. So when we apply that into that problem, then there we say that it is wisdom. That person has wisdom, like that. Okay. So when we move upwards in this hierarchy, the processing amount of processing will decrease. So processing data in order to generate information, it includes a very lengthy and very large amount of processing. Converting information into knowledge, here processing is, the amount of processing is less than the amount of processing happened here to convert data to information. Then using knowledge or converting knowledge into wisdom. So here what happens is we just use our knowledge and apply to a problem. We do not do any other thing. We just use our knowledge and apply to a problem. But here we take the data, we use certain theories or maybe certain tools, certain methodologies, maybe one or two or many methods in order to convert the data into information. And there are many steps. First of all, we have to clean the data, and then if there are error data, we have to remove them. There are lots of steps in order to convert data into information. But afterwards, the processing amount is very low. But when we move upwards in the hierarchy, the complexity increases, right? Looking at the data and getting an information is much easier than applying the knowledge in order to solve a problem, right? So the complexity increases when we are moving upwards in the hierarchy. Okay, so business intelligence includes these kind of technologies: online analytical processing or data warehouse, data mining. So business intelligence mostly use structured data, right? So what about unstructured data? So we will talk about these things. So here you can see an OLAP cube, or online analytical processing cube. So basically you have seen tables, you have seen graphs and matrices. I think you have seen those things. But here I don't know whether some of you have the experience, but here there is a cube, right? There are 3 dimensions where information can be stored. So here you can see this this axis, the x-axis includes a product category, right? Some category of a product, maybe the PC, book, shoe, clothes. So there is a category. This axis or y-axis indicates the quarters of the year, the first quarter, second, third, and fourth. And the z-axis mentions the territory, maybe the US, the Australia, like that, right? So when we get a certain cube from here, there is a product related to that cube, let's say book, and a quarter related to that cube, let's say the third quarter, and the territory, maybe Australia. So this cube can contain Australia. So if we take a cube around this area here, it will contain the US as the territory, right? Like that. So there are 3 dimensions, and information can be 3 kinds of information can be stored in a cube. So we say that this is a online analytical processing cube. So this is actually one way to store data, right? With relations with each other, it is a way to store data, right? So based on the amount of data, or based on the type of data, and based on the thing that you are using data, based on the reason that you are using the data, you can store, or you can you can store the data either in a 2-dimensional or 3-dimensional way, right? So when we talk about data mining, I'm not going to talk about data mining in a very lengthy way. Just want to introduce or mention that this data mining is included in business intelligence. So when we talk about data mining, it is actually a process that comes again and again, that happens again and again. So initially you have a business goal in your company, you have a business goal. So in order to accomplish that goal, you are doing everything, right? So first of all, you have data in your company. As I mentioned before, a lot of data is being shared and is being stored within your company. Sometimes data move out from the company also, and external data come into the company, like that. So you identify data. First of all, you identify data. So what are the data which is suitable for the certain process, right? You identify data, and then you prepare data. So identifying data means, as I mentioned before, there are a lot of types of data in a company. So for a certain purpose, not all that data can be used, right? All the data cannot be used in order to give answer to a certain problem, right? There can be certain related data, but other data might not be useful for that. So like that, you have to identify what are the data which is useful for a certain purpose, right? So you can identify data, and then after identifying data, after selecting a certain set of data, you have to prepare the data. So inside a set of data, there can be data with errors, right? For example, let's say if you are collecting scientific data, so scientifically measuring maybe some measurements. So when a person is measuring something, certain errors might happen, maybe due to the physical devices that that person is using at the moment, or maybe due to certain what do you say, climatical changes or environmental phenomena, anything. Certain errors or certain changes can happen to data. So if you are using erroneous data in your analysis, then the result also will be an erroneous result. So you have to, that's why you have to prepare your data. You have to look at your data, and you have to, if there are data with errors, you have to remove them, or you have to correct that data, right? Things like that you have to do in order to prepare data. So we will talk about data preparation and those kind of things in future slides, right? And then we can use the prepared data in order to build our model, or we can model the data, we can evaluate the data, we can use certain tools, right? So the analyzing part comes here. We can use certain tools in order to use that data and convert that data into a information. And then after converting that data into an information, you have to present that data, because you can view, or you can identify certain patterns, but it is useless if only you are able to view that patterns, if only you are able to identify certain patterns in the data. It is useless if it is only you, but you have to present it to the company, or by the company I mean the company directors and the managerial staff. So the managerial staff, normally they do not know the technical side, like data analyzing, those kind of things, they do not know, but they can understand the overall scenario when we explain it. So that's why we are presenting the data. So after we get a result, we present that result, or we present the data, and that presentation, or the information which is shared in that presentation, can be used to apply to gain business goals, right? So again, your business goals might change, and then again that circle moves on again and again. So new data will be added to your company, so you can use that new data in order to process and create new information in order to achieve new business goals. So it happens again and again, right? So data might differ due to various kinds of reasons, right? So that is basically what happens in data mining, right? So as I mentioned, as it is mentioned here, there are two types of data: structured and unstructured data. So structured data means that data is it is easy to understand. It is very clearly and properly stored, right? So like in a table or in a database, there are columns and rows. So under each column, a certain kind of data is being stored. So when we take one column, there is a certain data type. For example, when we take the column name, all the rows under that column, all the cells under that column includes names of maybe certain employees, like that. If the column mentions age, all the cells under that column contains ages, right? Like that. So that data is structured, right? Basically, what the data that we find in a database is structured data. So there are other kinds of data which is unstructured. Unstructured means we cannot put that data like this inside a table. So there can be text data, images, audio, video, a very large collection of data. So here you can see structured data might only include text data or any one type of data. But unstructured data, you can see there are many types of data. So when we take data in a company, there is a database in a company, right? People store data in Excel sheets and they upload that data into a database. And then there is also emails, forums, chats, right? Images, photos, recordings, right? Meeting recordings, online meeting recordings, those kind of things can also exist in a company as company data. So we cannot directly put that data into a database because the data types are different and they are unstructured, right? So that is the difference between structured and unstructured data. So when we take a company or a business, both kinds of data will be are available there, right? So unstructured data, when we deal with unstructured data, something called ECM. Right, ECM comes up. So what is ECM? ECM means Enterprise Content Management. So when we have unstructured data, we have to manage that data before you using that data for a certain purpose, right? So when we take a database or a table, we can directly use that set of data for maybe querying, for processing or anything like that. But if we have a set of unstructured data, we cannot query that data directly. We have to manage that content before doing anything to that data. So for that, we have enterprise content management. So you can check with Google, or you can Google it and you can see what enterprise content management is, right? So that is up to you. So here are some other differences or characteristics regarding to structured and unstructured data. So structured data, you can see there is a database. It is like a matrix, right? Data is stored in a very clear and meaningful, clear way. But when we take unstructured data, there are different types of data. There can be text data, audio data, video data, there can be tweets, maybe posts, maybe images, lots of kinds of data can be there, right? So structured data is predefined, is a predefined data model. The table is defined, right? There are certain columns in the table. We have to include that data matching to those columns only, right? So basically structured data comes with the text only, and it is very easy to search. When we look at the table, or we can search a certain data, we can query a data. But when it comes to unstructured data, there is no predefined data model. We cannot say that this text data, audio, video data should come up with under these columns. We cannot say like that, right? It can be text, images, sound, video, any format, and it is difficult to search. So if we want to search something, maybe if you want to search how much sales have been done in a certain year, using this unstructured data, it is very difficult to search, right? So structured data resides in a relational database or maybe data warehouses. Unstructured data can be found in applications, maybe databases, data warehouses, data lakes. They can be found in lots of locations, right? Both structured and unstructured data are generated by humans or machines, right? People can input data, or data can be uploaded using an application, right? So usage of structured data, some examples are airline reservation systems, inventory controls, CRM systems, ERP systems. So you can search for this information, what kind of systems these are. You can search them. So I have only given you the examples. So when it comes to unstructured data, it can come under unstructured data can be obtained from word processing applications, presentation software, emails, tools, from any application. Unstructured data can be obtained, right? So structured data, some examples of structured data will be dates, phone numbers, social security numbers, anything that we can put into a table. But unstructured data, we cannot say that this kind of data like that, we cannot say. So unstructured data can be text files, reports, email messages, audio files, video files, images, surveillance imagery, right? So if you have a CCTV camera in your office, then a very lengthy video will be recorded using the CCTV camera. So that is also data, but it is unstructured. Okay, so yeah, this is a little bit about enterprise content management, as I mentioned here. So if you are dealing with unstructured data, we can use enterprise content management for that. So enterprise content management means basically managing the content in the enterprise, managing any content in the enterprise. So integration of knowledge or data. There can be data or there can be knowledge in a company, maybe within the company, or maybe with the company and its outside dealers. The whole thing is integrated, whole thing is connected, right? So documents, pictures, project databases, everything is connected with each other. Unstructured or semi-structured data can be available in enterprise content management in this process. This is a process actually, right? So we can use chats or discussion forums, news groups, document management, yellow pages, project databases. So data from all of these applications can be taken and connected with each other in the enterprise content management, right? So certain ways or certain certain models have been built in order to connect the enterprises or connect maybe the departments within the company, maybe the branches of the company. So after connecting, the data can be flowed, or the data can be obtained from any part, right? And relationships can be built. So things like that can be done in enterprise content management. Okay, so this is another another small activity for you guys. So here you can scan this code again, this QR code again, and there is a question: why do we need business intelligence? So you can answer that question. There will be a small place to answer that question, or you can go to the link that I have given here. And answer it. Okay, so you can submit several answers here. Why do we need business intelligence? You can submit several answers. Okay, so I'll give you a little bit of time and we'll have a small break before continuing with our other other part of the lecture. Okay, any questions so far? Any questions or anything you need to say, whether I am explaining very fast, or do I need to explain again, anything like that? Do you have any questions? Yeah, no issues. Okay, then you can scan this QR code and you can give answers to this question: why do we need business intelligence? And we'll have a small break for about like 15 minutes or 20 minutes, right? A 20 minutes break, and we'll continue the lecture again. Okay. Hello. So, have you given the answer to this question that I have asked you? Okay, so why do we need business intelligence? So these are some answers given by maybe you, maybe the people in the previous batches. Okay, so you can see this, right? Okay, so why when we ask why do we need business intelligence? Mm, there are several answers given, so you can view these answers and see. So basically, some people have said to improve the business operations, to identify competitors, maybe identify business trends, improve performances, track performance, to make better decisions, right, and make decisions. So making decisions has become uh, a reason, a main reason for business intelligence. Why uh, we need business intelligence. So and also to grow business, identify new opportunities, learn about the business, uh, right? So making decisions again, yeah, things like that, right? Optimizing performance. So you can see when you read all of these answers, it tells you something to for the betterment of the business, right? To do something for the betterment of the business, we need business intelligence, right? Business intelligence can be used for the well-being of the business. So basically, in order to do something for the well-being of the business, certain decisions should be made, basically by the management itself. Certain decisions should be made. So these decisions should be accurate and should be the best decision that can be happened in the business. Otherwise, if a wrong decision is made, then the business will not be right. There will be a downfall in the business. So so business intelligence is basically used in order to make better decisions for the betterment of the business, right? So that is the main reason for the usage of business intelligence. And by making these better decisions, the business will be improved, or more profits will be generated in the business, things like that. Advantages, such advantages can be obtained, right? Okay, so yeah, so this is the need for business intelligence. Why do we need business intelligence? So basically, business intelligence can be used to improve the quality and speed of decision making. So as I mentioned, the best decision or a good decision should be made in order for the business to be improved. And this decision making should be improved also. The making of the decision or the quality of the decision should be improved, right? And the speed of decision making. So we can make a decision, but in order for the best result to come, in order to the best result to outcome, that decision should be made quickly, or in the in the ideal time, right? Sometimes you can see a very good example in the government in Sri Lanka, not only this one, the previous ones also. Most of the governments, they make decisions after some crisis happens, right? Mostly they make decisions after certain crisis or certain thing happens, right? That decision should be made previously, right? There are some decisions, those decisions should be made prior to certain incidents. But some governments have failed in decision making. They have failed the speed of decision making, right? So there are experts in the country. So the experts when the experts tell something, it should be considered by the government, right? So same goes with the business, with the company. So there are certain experts in the company, basically in the management level. So these experts, when they say something, it should be considered, it should be concerned, right? And certain decisions should be made in a speedy manner, right? Even though a certain decision is made after some tragedy or after certain circumstances occur, then it is not useful, right? So business intelligence can be used to improve the speed of the decision making. So certain computerized tools or software or certain technological tools can be used to make speedy analysis and therefore make speedy decisions, right? And business intelligence can also be used to facilitate strategic planning. So whenever a plan is executed or whenever a plan is created in a business, within a business, there should be a certain strategy, a certain way in executing or in executing that plan. So we can use the results from business intelligence in order to facilitate, in order to improve this strategic planning, right? Business intelligence can also use to optimize resources, right? All the resources in the company, maybe physical or virtual resources, can be recorded, right? They can be recorded, they can be audited, right? So certain business intelligence tools and theories can be used to optimize the usage of this resource, right? Resource optimization. So there can be many theories, many tools and technologies in order to perform these resource optimization tasks, right? certain applications, certain software can be used for that. Enhancement of sales processes. Business intelligence can be used in order to enhance the sales of the company. So certain 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 like other companies, their other products and external sources can be used in order to make a better decision, make better decisions in order to increase the sales of a company. So processes can be optimized, more resources and various kind of strategies can be applied in order to enhance the sales processes, right? So business intelligence can also be used to share intellectual capital and knowledge. So this is, for example, when we take one company in one location, there can be other branches in other locations. So these branches itself can share their knowledge, their intellectual capital, those kind of things, right? And also companies and other companies, maybe certain companies and other companies which are there in the similar field, those companies also can share their knowledge and intellectual capital. Some companies might request or might take services from other parties, right? For example, a company or a business, if the business is more focused to textile management or textile creation, textile creating, if the company is focused to textile creation, the management part might be outsourced from another company. So things like that happen, right? So when a software company, most of the software companies do these things. So building the software or developing the software is done by one company. Then maintenance or support services are provided from another company. So things like that happen. So the support services are outsourced. So the knowledge and the intellectual capital will be shared, can be shared easily between those two companies with the help of business intelligence, right? So business intelligence solutions, some solutions I have listed here. So one is customer analysis. We can analyze our customer. Okay, so can you go through this this statement here? What does it mention? Okay, so in customer analysis, what we are going to do, what we need is we can analyze the customer. It is basically we have to understand the customer. The need is to understand the customer. So when the company understands its customer, the company will be able to provide customer friendly services or services which the customer is happy with, right? So better understanding of the customer behavior, maximizing customer value, measuring customer satisfaction and loyalty, these kind of things can be provided in customer when we do customer analysis. So let's take a bank. So in a bank, if the customer is a credit card holder, the bank can measure or the bank can monitor the customer's behavior in spending the credit card. So the maximum amount, the normal maximum amount the customer usually pay is recorded in the bank. So whenever the customer or maybe whenever the credit card is due to pay a very large amount or an unusual amount that is being done regularly, then the bank will understand it. The bank will be notified, right? Then the bank can discuss or call the customer and make sure that that is the same customer who is doing that payment with the credit card, because any fraud thing can be detected, right? So by measuring the customer behavior or monitoring the customer behavior, customer satisfaction and security can be provided. So customer values can be maximized by providing certain loyalties or certain like golden customer, silver, bronze, things like that. We can give a value to the customer. We can say that the company can say that you are a bronze customer or you are a golden customer, so you will be receiving these kind of services like that. So customer satisfaction can be measured by recording customer reviews, comments, things like that, right? And the customer loyalty also can be measured. So those kind of things can be done and measured using customer analysis. So business intelligence, one of a business intelligence solution is that customer analysis. Then we can also analyze our productivity, the company's productivity analysis. So how much is the quality, or how good is the quality? What can we do to improve the quality? Can the quality of the product can be improved? Things like that can be measured, or decisions can be made using BI solutions. Fraud and defect analysis. If the products have any defects, if the products are fraudulent, then that also can be measured using these productivity analysis tools. Capacity, how much capacity or how much how many products should be generated, things like that. Asset management, what are the assets that the company have and how much production is needed. Those kind of decisions can be made through business intelligence solutions. Then performance analysis. BI solutions can also deliver performance analysis. So the performance of a company, performance of its human, financial, equipment and assets. How much human assets are there, and what is the performance? What is the financial performance based on the what do you say, things that are happening in incomes and those things. What is the performance, right? Or we can also we can measure it, and we can also make decisions in order to optimize how the business use its resources. So the resources are generally human, financial, equipment, and assets. So how these things can be used, how these things can be maintained, those kind of decisions can be made using business intelligence solutions in performance analysis. Supply chain analysis. Monitor and improve supply chain activities from material ordering through product or service delivery. From the moment the materials are ordered in order to produce a product, and up to the point where the product is delivered to the customer, all the processes are included in the supply chain. So we can analyze this supply chain, how much material, or what are the quality of the material, or from where the material are being purchased. Those kind of data and information can be used for this analysis purpose. And throughout the chain also, everything can be monitored, and everything can be improved, and even the delivery part also can be improved and monitored, right? So supply chain analysis is done like that. Then there is sales market analysis. So the marketplace can be evaluated. What are the trends? What is the best price today? What kind of quality are the products nowadays? What is the new technology? Those kind of things can be evaluated. The market, what is there in the marketplace, right? And after evaluation, we can develop and implement sales, and we can create marketing strategies. We can use feedback of customers in order to enhance sales processes, right? So this is based on the sales and market, right? So based on the new trends in the market, we can develop, or we can implement sales. So for that, we can use new marketing strategies. We can also use feedback of customers in order to enhance the sales process. So all of these things can be done through a business intelligence solution. So business intelligence solution nowadays means basically a software, an application. You can search the web and see there are very large business intelligence solutions. So these business intelligence solutions are actually, they can actually be applied for large companies. So if you are working in a, you can go and ask your company, your supervisor or your manager or whoever, maybe there are certain business intelligence solutions they are using, but large companies, like large software companies, for example, they use BI solutions, solution applications, right? So these applications do all of these things: customer analysis, productivity analysis, performance. These steps, or these things are usually done in through a BI solution application, right? Okay, so these are some examples which are created using BI solutions. So credit scoring, bond ratings, insurance claims, census data, severity of accidents, marketing, right? So these business solutions are provided in these fields. So you can search about these things. These are some examples actually. Business solutions for credit scoring. So bond rating is one kind of business solution. Insurance claims, how they work, that is one kind of business solution, right? So you can, these are, you have to read about them practically, how these things are happening. right? And I have also given you 2 links. You can go to them and see. Let me check whether they are working now, because I have included this some time back. Okay, that video is not available. Okay, so this is one business intelligence solution application. Remember I mentioned BI application, applications which give BI solutions. So okay, I hope you can see the screen, and yeah, I'll play this video so you can get an idea about what a business intelligence solution is.
Pharmaceutical companies worldwide are inundated with data at a time when the commercial landscape is changing and sales forces are being reduced. There is now an increased importance of having effective customer analytics in order to drive greater ROI from existing investments in people and technology. Providing greater ease of access to this data enables faster, more effective business decisions. There is the constant challenge of turning this complex data into valuable insights, and typically analytics capabilities within CRM solutions are simply not sufficient. Data intelligence specializes in pharma data. We understand how to model your pharma-specific business structures, business rules, data sources, supply chains, and local healthcare environments, so that together we can provide holistic pharma business intelligence to your entire commercial team via multiple devices, both online and offline. Delivering and managing an effective BI solution is no longer a time-consuming and fragmented process. We focus on providing better business insights, leading to better decisions, improving performance. Our Pharma Analytics platform is configured and tailored to the individual user wherever they sit within the company, designed and harmonized centrally, yet accurate and relevant locally. We provide an end-to-end solution which draws sales and marketing data from any source, wherever it comes from, designed to change quickly within a secure, effective software as a service model, continually evolving and changing to reflect the business environment. With our help, efforts go down, results go up. The result is a proven approach providing scalable BI capabilities to meet the individual needs of pharma executives. Learn why 8 out of the top 15 pharma companies are using data intelligence worldwide. Telephone +44 0 1753 245503. www.data-intel.net.
Okay, so as you saw, so this is a business intelligence solution based on pharmaceutical companies. So these solutions are given. Solutions means this is actually some software application which you can call and get from this company, Data Intel company, right? So what they do is they do health analytics. They analyze certain details related to health. So basically, healthcare companies can use this business intelligence solution in order to increase for the betterment of their company, right? So this is you can see this is based on the healthcare system. So this is a business intelligence solution for the healthcare field, right? So like that, business intelligence solutions can be provided for different fields. So different kinds of applications can be made in order to provide certain solutions. So here you can see, so they provide this application have the desktop application, the tablet or whatever this kind of application, and a mobile application. So any device, this application can be used with any digital device like this, right? So that is one example for a business intelligence solution. Okay, so yeah, I'll remove this link because it's not working anymore. So these are some examples. So you can similarly, so the link that I have provided gives you an example of BI solutions in the healthcare system. So similarly, you can search for these credit scorings, bond ratings, how they are provided, what are the business intelligence solution there. You can search and read about them. Okay. Okay, so next we will be talking about the BI umbrella. So the BI umbrella, it is a hierarchy. So from bottom to top, you can see at the bottom there are raw data sources, right? Raw data sources. So for example, paper, files, information providers, databases, online and online transaction processing, those kind of things. Data sources, places where we can obtain data, or places where we can get data from. So these are data sources. And then in the next level, we can query data, we can build queries, we can build reports. So when we look at these queries, or when we look at the answers from the queries, or when we look at the report, we can understand something more than just the data, right? We can understand something more than the data, more than just looking at the data, right? So we call these queries, the collection of queries and reports, we call them a data warehouse. Collection of queries and reports we call as a data warehouse. Okay, so we can do online analytical processing using these data warehouses. So that is, so there can be many data warehouses, many types of data warehouses. So we can link those warehouses, or we can perform analysis online. So that is online analytical processing. So that can be called as data exploration. So in the name itself, you can understand we are exploring the data from different kinds of data warehouses, right? Not data sources. We are not here, we are not taking data from files and databases like that. We are directly accessing data warehouses, right? Which are the queries and reports based on the raw data. So when we explore this data, we can build a knowledge, or we can identify certain patterns, or we can understand certain things. So that is, we can discover knowledge, right? When we link these data warehouses and when we explore the data, we can discover knowledge. That is called data mining, right? That is called data mining. We can understand certain things in that set of data. So that is data mining. And when we put this knowledge into visualization techniques, we visualize what we know, right? So in the video that you saw previously, I think you were able to see certain charts or certain visualization was done related to some information or something that is being said in the video. So similarly, what we have discovered here can be visualized maybe by using maps, charts, or graphs, anything, right? So visualization techniques, when applied visualization techniques, we say that is data presentation. We present the data to some external source. Okay, we present the data. So data presentation is happened at this level, right? And then based on the data that was presented, certain decisions can be made, right? Making decisions. So decision making is the final step of the BI umbrella. So this is the final task, or this is the optimal task. This is the reason why we do all of these things, in order to make the best decision, right? So when we go throughout this BI umbrella from bottom to top, this data mining, people who do data mining is called as a data analyst, right? People who write a software or develop a software is called a software engineer or a developer. So people who do data mining, that person is called a data analyst. A person who does data presentation is called a business analyst. So business analyst, what a business analyst usually do is, he take the data which is mined or the results obtained from that, and he present the data, right? The end user or maybe the directors and the management level, basically the topmost hierarchy of a business, is the one who is making a decision, right? So basically the director or the topmost person in the business makes the decision. So that is the end user. That will be the end user, right? So when we move on from bottom to top, the optimal use of company data and knowledge to support business increases. Like the optimal usage of company data is made when we move from bottom to top, right? So all the raw data is being used in certain levels and finally come up here to make decisions for the company. Okay, any questions? Did you understand this? Did you understand the concept of BI umbrella?
Yes, ma'am.
Okay. Okay. So, yeah, so that was about business intelligence and business intelligence solutions, why we need business intelligence, those kind of things we talked, right? So next we will move on to talk about data. So in order for the business intelligence applications or for the business intelligence solutions to work correctly, a large amount of data is required. So normally in a company or in an organization, as I mentioned previously, there are different ways where data is obtained and data is generated and stored in various places in the company. So whenever the person or whenever the team who is responsible for optimizing the company or the organization, they have to collect the data, measure the data, and put that data into a computer analysis technique, right? They have to collect the data, measure the data, and put that data into a computer and do some analysis in order to obtain a certain result. And based on that result, they will maybe create a data visualization part, or data presentation can be done, and the management or the end user will make the decision. So the end user cannot come up to a decision unless the end user is aware of what is happening in the company, what is the current status. So all those things should be visualized to the end user. So the person or the team who is doing that part, that visualization part, they have several steps to do. So it is like the things that came in the BI umbrella, right? So when we talk about data, data can come in different sizes. So the smallest size of a data is a bit. I think you know, you have learned about this bit, byte, megabyte, gigabyte, kilobyte, those kind of things. I think you know. So bit is 1/8 of a byte. When we take a data byte and divide that byte into 8 parts, one part is known as a bit. So bit is when we take a letter and divide the letter into 8 parts, one part is not known as a bit, right? So 8 parts like this, when connected with each other, it performs a letter. A letter means any letter that is available in our keyboard. So for a letter, 1 byte of data is created, right? One letter has the size of 1 byte, which means 8 bits, right? So there is a half of this letter which is called nibble. So half of this letter is called a nibble, right? Or okay, so this data size is normally not used much, but a bit and a byte is normally used, right? So 8 bits are used in order to store one letter in our memory system. Then there is a megabyte. Megabyte means normally it takes the data size of a book, and a gigabyte takes a size of 1600 books, right? Then there is a terabyte, right? You can see the picture, right? Then there is a petabyte, this amount of books, right? And 1 exabyte. So 1 exabyte is equivalent to about 3000 times the entire content of the Library of Congress. So you can see, I mean, you can get the idea about the size, right? What is an exabyte? So, and for an exabyte, when we when we pile the books one on top of another, only 10,000 miles short of reaching the moon. So if we put books one on top of another on the earth, for an exabyte, to gain an exabyte, there will be a huge pile like this, and there will be a small only 10,000 miles of distance from the topmost book and the moon, right? So that is just a calculation, right? So 2.5 quintillion bytes of data are created daily, produced by everything from photos uploaded to social media website, to weather balloons, to Curiosity or rover currently exploring Mars. So there are a lot of data uploading for different places daily, right? So 2.5 quintillion bytes. That is a very large number, which is uploaded daily, right? So any data which is bigger than big data is this one, bigger than big data. So normally we say this kind of data we mention as big data. Then there are data which is bigger than big data. So this is 1024 exabytes is called a zettabyte, like that, right? So this kind of data is unable to be processed because there are no even supercomputers cannot process this amount of data at once, right? So that is about the just for you to get an idea about the data sizes. Okay, data can be obtained using internal sources and external sources. So internal sources means transactions, mailing list, intranet within a company, right? So the company can have certain transactions within itself, and people will mail or chat with each other within the company. There can be an intranet, the network within the company. So those are the internal sources of data. The external sources of data is obtained when the company deals with anything external. Claim records, when the company is claiming something from outside. Demographic data, internet data, those are the data which is created when the company deals with something outside, right? So geographical data, cultural data, scientific data, there are many kinds of data which is related to a company, or maybe related to you and me also, right? So data type can be numeric, or we can also say continuous, or data can be discrete, right? So continuous data means infinite set of values. We cannot say that this data has this limit. There are unlimited set of values in numeric data. So for example, when we call integer, when we talk about integer type of numeric data or continuous data, there can be age. Age means I can be like 30 years old, or 30 years plus 1 day old, 30 years 1 month old, 30 years 2 months old, like that. We do not have a limit for age, right? Age can be defined in any way, maybe 3.5 years old, 3.75 years old, we can say like that, right? So 3 years and 6 months old, like that, right? Zip codes also. Whenever a new village or whenever new country is being created, then a new zip code will be introduced. We do not have a certain limit for that, right? So real-time data can be temperature, continuous data. Temperature can be 100 Celsius, 100.1 Celsius, 100.2 Celsius, right? 102, like that. 100.35. We do not have a certain limit there, right? Same goes to height, right? 6 feet, 5.5 feet, 5.7 feet, anything like that, right? So these data types are continuous. So height, weight, salary, temperature, interest rates. There can be integer data as well as decimal type of data. So then there are discrete data types. Discrete data type has only has a finite set of values, right? For example, there can be low, medium, high. There are only three types of data, three set of values, right? Three values here: low, medium, high. We can say my income is a very low one, my income is medium, my income is high, like that. Or we can give colors: red, yellow, blue, right? We cannot say 5.5 red, half yellow. We cannot say like that. If it is red, it is red. We can say like peacock blue, like that we can say, but there is a finite, or there is a certain color like that. Peacock blue is peacock blue. We cannot say it is half peacock blue, it is 3.5 peacock blue, like that we cannot say. Okay. And binary data, either it is male or female or any other category, but there is a certain set of categories. There are finite number of categories here, right? 0 or 1, on or off, yes or no, yes, no, maybe. So like that, there are a finite set of values. So discrete data can be used in units, number of units sold, number of languages spoken, number of students, like that. So normally there are no decimal data in discrete data types. So data can be represented in certain forms. Right? We can use a matrix in order to represent customer data. So the customer data, set of data, the customer name, the age, the address, telephone number, those kind of data can be stored in a matrix or a tabular form. Tabular form means a table, mostly as a database, right? And we can also store data in a multi-relational form. For example, a family tree. I think you know about a family tree. So the grandparents or the great-grandparents are on the top. The children of the grandparents, which are maybe your mother, father, aunt, uncle, those people are in the next level. Then comes your generation, then maybe your children, like that. So your spouses, like that. So that is a multi-relational data, right? Then there is time series. time series are normally indicated as charts or graphs. So monthly profits, daily rainfall, that normally this kind of data can be visualized in a chart or a graph, right? Then there are spatial data. Any data which can be represented on top of our in a certain space, right? For example, maps or routing information, the path or the path to go from one location to another, right? So when we take maps, when we look at a map, what do we have on a map? On a map, we have certain geographical differences. For example, roads, railway tracks, and then lagoons, trees, things like that. And then man-made monuments, buildings, those kind of things also we can see on a map. So what we are seeing is we are taking one space in our world, and then we are looking at what kind of things are there in that particular space. So that is called spatial data, right? Then string sequences, DNA or RNA strands. So these are large strands. These data are normally shown as strands. So what is that? DNA. I think you can see how this DNA is drawn, right? So if we take a DNA structure, okay, so this is normally if you can see this image, I'm sorry, it's not coming. It is a strand like this. The DNA, what do you say? This, I'm not a biology person, but this DNA, I don't know, maybe elements or something. So they have given certain letters, right? So T, A, C, G, like that. So these are the elements, or what do we say? Yeah, these are the elements which are there in the DNA. So these letters are actually given for the people, for the easiness of the people to identify. So you can see this spiral structure here. When we zoom into this spiral structure, you can see there are certain DNA strands, right? So it is a long, it is like a long sentence with these letters T, A, C, G, right? So that is a string sequence. That is called a string sequence. Same goes with RNA. So that is how that data, the information regarding DNA is stored, a sequence, a string sequence, right? Then there are hierarchical structures, where university structures or structures of a business organization. There are hierarchical structures. Who are the employees, the topmost level, who are the topmost level, who are the managers, then who are the supervisors, like that. There is a hierarchical structure to store data. basically in university or any other company, right? So these are some forms where forms of data where data can be stored in certain ways. Right. So the most important and the most popular type of form data is known as the table or matrix form data. Okay, so a table or a matrix have the same fixed set of attributes. So the column names are fixed, and the types or the cells which are coming under each column contains the data type given by the named by the column, right? For example, under the ID column, all the cells contain IDs. Under the marital status, all the cells contain the status, either single, married or divorced, like that. Under the income, all the cells contain the data regarding income. So under this income, there is no data regarding marital status, like that. It has the same fixed set of attributes. So this kind of data can be represented by NNM matrix, which means there can be many number of columns and many number of rows. N number of rows, one for each object, M number of columns, one for each attribute. So the column names we also call them as attributes, and the objects we name them as the rows. The rows we name as object. So when we take one row like this, that is one object, right? So this is one person actually. The person's ID is 1, his marital status is single, his income is 125, and he has a laptop, right? So this is another person. This person's ID is 6, he is married, he has 60K income, and then he has a laptop, like that. So that is one object, right? So that is about 2D at 2D form of data, or table or matrix. Then we can also have a 3D form of data. This OLAP cube I have explained before. So 3 dimensions: product category, quarters, and the territory can be shown here, right? So we also mention them as multi-dimensional data cubes. So OLAP cube is a multi-dimensional data. So we can store several dimensions of data. Unlike here, we can only store 2 dimensions of data, which are attributes and objects. Okay, so when we talk about data, we should talk about data quality. Remember, I mentioned before, after we collect data, we have to make sure that the data is of good quality. Otherwise, our results will not be an optimum result, right? So the quality of the data, or whether the data has lot of errors or not. So those kind of things we should concern before moving that data into analyzing. Before using the data for analysis, we have to make sure that the data has a good quality, right? So in order to understand that, we have to understand why. We have to identify why the data have quality problems. How does the data decrease the quality, decrease its quality? So when we record data, or when we gather data, when we collect data, the data can contain noise or outliers. The data can contain missing values. there can be duplicate data. So these three things, noise and outliers, missing values and duplicate data, is a direct reason to decrease the data quality, right? So what is a noise and outlier? What is a noise and outlier? Okay, so I need you to go through these paragraphs here that I have given here. First read this, and I need somebody to explain what he or she has understood. Okay, so I will be asking one of you to explain what is a noise and what is an outlier. So please go through this first, and let's see how you explain it. Okay. Okay. So have you finished reading? Can somebody explain what a noise is? Okay, there are only two people. So any one of you, one explain what a noise is, the other one explain what an outlier is. Mihiran?
Yes, ma'am.
Yeah, can you explain what a noise is? Regarding data, what is a noise? Did you read this slide?
Yes, ma'am, but I not got any idea for that noise or outliers.
Okay, whatever that you are thinking, whatever idea that you have, can you tell? Yep. Okay, can we have Himash, right? Is it Himash? Yes? Himash, can you, Himasha or Himasha, I'm sorry if I am wrong. Can you explain what a noise is? Yes, I need any one of you to explain what a noise and outlier is by reading this slide. Okay, then you can.
Noise is the random errors for during collecting the data.
Yeah, noise is something that we do not want, right? Noise is something that we do not want. So, for example, in sound, when it comes to sound, what do we say? Noise. Why do we say noise? We do not like to hear noise, right? So when we are listening to a music, if there is a noise happening around, we do not like it. That is an unwanted thing, noise. So here also, when we are recording data, when we are collecting data, unwanted things or unwanted data, or maybe a part of data, can be mentioned as a noise. So normally what noise is a random or undesired variations of one or more characteristics of any data object. For example, a bulk of messages in a news group that don't add anything to the discussion. Okay, so for, let's say you are having a group chat, right? You are having a group chat. Then maybe let's say one of your friend has is ill, so you are chatting with several people in order to maybe help that person, maybe to collect some money and give to that person, like that. So you are or you are asking for ideas of how to help that friend of yours. then your other friends are giving suggestions, so we can do these things, we can go and see him, we can collect some money and maybe transfer online, so things like that your friends will suggest. And in the middle of the chat, another friend says he comes with another topic, like the current situation of the country. Then another person say, yes, this government is not doing anything, we should chase them away or something like that. Then that your discussion becomes a political based discussion. Then one political party, then a person of one political party will blame a person of another political party, like that. So it is not related to the topic that you have created the group chat for. I think those things happen, right? You might also have such experience. So your initial discussion was based on helping your friend, but then another topic has come in the middle and it is not related to that discussion. So that is a noise. That other topic that came in the middle is a noise. It is an unwanted thing that came, right? So if we are collecting all the data in that group chat that you have created, so the data that we actually need, the data related to helping your friend, is only a part of that chat, right? Because the other part of that chat is related to the political discussion, right? So that is noise. So if you want to do some analysis based on what is the best way to help your friend or something like that, then we should remove that political discussion part. Otherwise it is not related to the main topic, right? So that is a noise. So we can remove noise or we can avoid noise by several techniques, but here what we are talking is, we are talking about noise. So noise is an undesired variation or something that we do not want, right? Another example of noise is distortion of a person's voice when talking on a poor phone. So when a person is talking on a poor phone, maybe a phone which is broken, or maybe a phone with a very poor signal, then only parts of the person's voice can be heard, right? So there can be other noises, random noises that we do not want to hear might come, right? So that is noise. So when we collect data also, data which is not related to our collection might also be recorded, right? So that is that kind of data is called as noise. Outliers means data objects with characteristics that are considerably different than most of the other data objects in the dataset. So for example, you have a credit card and you normally do certain payments. So your payments normally differ from like 5,000 to 50,000, right? Let's say you normally do payments of 5,000, 4,000, 10,000, 50,000, like that. Payments larger than 50,000 you do not do using credit card normally. Let's say your credit card is robbed by a robber. Then he goes to a shop or somewhere and he tries to pay a very large amount, let's say like 1 lakh or 2 lakh, very large payment. He tries to do a very large payment using the credit card that he has stolen from you. Then that is an outlier. So that payment amount is an outlier, because it is not the that amount is not in the general range of the credit card. So you normally did payments from 5,000 to 50,000. So 1 lakh or 1.5 lakh means it is way beyond the usual payment that you do. So at that moment, the bank will identify that there is something fishy is going around, and then the bank will call you and confirm whether you have done the payment or not, right? So that is outliers. So outliers can be used in credit card fraud detection, defect detection in manufacturing process. So there can so when certain products are created, if there are defects or issues in certain products, those products will be outliers. They won't be normal products, right? So anything which differs from the normal things or normal ways is called an outlier. So we have to handle this noise and outliers. So we can do data cleaning. Data cleaning means we can remove. So for example, we can take noise and we can remove the noise. In that group chat, we can remove the chat which is related to political parties, or the political chat can be removed. Okay, so that by that we can clean the data, but we have to be careful when we are removing outliers, because sometimes even though we see that as an outlier, it might not actually be an outlier. It might also be an unusual record of data, right? So when we are removing outliers, if you want to remove outliers, you should be careful. Before removing it, you should understand or identify whether that is actually an outlier or not. Then there is another way where data can be where the data quality can be decreased is missing values, right? Missing values or missing data. So why missing data is created? So missing data means the reasons for missing data can be information might not be collected. When you are collecting data, certain data might be unable, you might be unable to collect certain data. For example, let's say you are asking some people to fill a form, or to fill a form. Then certain people might not be happy to give their age or weight, right? So mostly the female gender, they do not like to reveal their age, and again the female gender, they do not like to reveal their weight, some people. Okay, so in that form that you have given, they will not include their age or weight. So after you collect all those forms, you won't be having values for age and weight for some people. So that is missing values, information not collected. Sometimes attributes might not be applicable for all cases, right? So for example, if you are giving a questionnaire to people, then you are asking for the driving license number of your driving license number. If you are asking for the driving license number of that person, then some children who are filling that questionnaire might not be able to provide that answer, because children do not have a driving license yet, right? So things like that, due to some cultural differences, due to many reasons, there can be missing data. Some data might not be able to be recorded. So what can we do in order to handle missing values? We can either remove the total object. Object means the total row, like this. So this number 4 is the object. Let's say the marital status of this person number 4 is not recorded here. Let's say it is a missing value. Then we can, in order to remove missing data, we can remove the whole row. The total row or this number 4% will be removed from the data collection, right? Or we can estimate missing values. We can estimate a value and we can put into that place where the missing value is, where the missing data is, right? Normally by computing the average. The average income. So like here, let's say the income of that person is not included. So let's say this is a divorced person. So we will calculate the average of other divorced person in the list, and we can calculate the average income, and then we can put that calculated average income here, right? So we can estimate a missing value and include it, or we can just simply ignore the missing value when we are analyzing. So even though there are missing values in the data set, we just ignore it and just keep on analyzing the data, right? And the next way how data quality is decreased is duplicate data. So sometimes due to certain reasons, data might be duplicated. Okay, data objects that are the same or almost the same can be recorded. So this thing normally happens when we are merging data from different sources. Let's say you are collecting a set of data and your friend is collecting a set of data, then both of your data will be merged together in order for analyzing. Then sometimes the data will be duplicated. Okay, it occurs when merging data from different sources. For example, same person with multiple addresses, different insurance policies. So the same person, so you, let's say one of you go to a school and you give a form or something to record some data from the students. Then another person, another friend of yours, he also goes to the same school and he gives another form, another type of form to record some data. Then according to your project, all of those data should be merged. Then when you are merging, the same student might be there with maybe, I don't know, with different subjects, right? So one student might be doing several subjects, or he might have filled several sets of forms like that. So anyhow, data will be duplicated. So how do we handle duplicate data? We can do data cleaning, like in the previous slide. We can just remove any duplicated data, right? If there are several sets of data, we can remove certain sets of data and leave only one remaining. Or we can give complex name records. We can name each and every set. We can give a different name or different number. Even though there are duplicate data, we can give a different name or different ID in order to handle the duplicate data. Okay. Okay, so next we have to talk about data collection and then data preparation, like that, and then we can move on to data mining. So since it is a very somewhat a lengthy set of topics, we will stop for today from here. So from the next week we will talk about data collection and move on So we have to talk more about quantitative and qualitative data collection, those kind of things. Then we have to talk about how we are going to prepare data for our analysis, and then how we are doing data mining and things like that. Okay, so any questions up to now? Up to this point? Any questions up to this point?
Ma'am,
Are
can
you?
you yeah, ma'am. Can you again explain outlier?
Outliers.
Please.
Okay. Okay. Outliers means anything which is abnormal, right? Different than most of the other data. Any data which is different from most of the other data. For example, if I take the same example that I have mentioned before, let's say you are using your credit card and you normally do payments, let's say you normally do payments lower than 10,000 rupees, right? Small payments. You never do payments higher than 10,000 rupees. Okay. Then one day the bank sees that your credit card is trying to do a very large payment. Let's say 1 lakh, a payment of 100,000 rupees is being requested to be done by your credit card. Then the bank sees the bank thinks normally you do payments less than 10,000, then why are you doing there is a payment which is unusual, a payment of 100,000, right? So 100,000 is an outlier there because the normal values are less than 10,000, right? The normal value is less than 10,000. 100,000 is an abnormal value. So 100,000 will be an outlier there. Did you understand?
Yes, ma'am.
Okay. So any data object with characteristics which are different from the most of the other data objects. So your usual payments from the credit card will be less than 10,000. It can be 5,000, 8,000 or 10,000 like that. Normal your credit card payments are like that. But one day a payment is being requested to perform and that payment is 100,000 payment. So the bank will detect this as an unusual thing. Then they will call you and ask that your credit card is trying to do this payment. Is this you? Are you actually doing it? Then you might check for your credit card and it might not be with you, right? It might be stolen from some other person. Things like that is detected, right? So outliers means something which is very different from most of the other data objects. Okay, so any other questions that you need to clarify? No? Okay then, so we will talk about the other from data collection and the other steps for data analysis. We'll talk about them on the next week, and we'll also talk about your assignment structure on the next week when the other people are also there. So you keep that assignment structure in your mind so that it will be easy for you to because finally you will be having an assignment and a presentation, so you must be ready for that. So we will talk about that structure also generally, very briefly. I'll explain about that structure on the next week, so you can keep that in mind and work towards it. Okay then, so Yeah, if you do not have any other questions, let's stop for today then. So until the next week, have a nice week. And thank you very much.
Thank you, ma'am. Thank you so much.
Thank you, ma'am.